I'm Sankirtana from EC department. My topic is about designing a binary clock using logic gates. There are 5 steps involved. Step 1, schematic and paths. The paths required are clock crystal, capacitors, resistor, ripple counter, 2 into 408 IC dual 4 input AND gate, 1 into 2 1 mm plug-in, 17 into LED, red, yellow, green or whatever you like, 17 into 470 ohm resistors. I used the 9 volt supply so that the output from the pins is something around 9 volt. Typical forward voltage for these LEDs are about 2 volts. Step 2, testing. How it works. 4060 is a 14-bit ripple counter with internal oscillator, and it gives with the 32768 Hz crystal 2 Hz signal at the last output Q14, which is pin number 3. Then the 2 Hz signal goes to 4024, which is also a 7-bit ripple counter. With the 2 Hz clock input, the output Q1 pin number 12 is low 1 second and high 1 second. Q2 pin number 11 is low 2 seconds and then high for 2 seconds. Q3 is low for 4 seconds and then high for 4 seconds. In the last 4 most significant digits 111100 equals to 16 goes to 1. The 4082 dual 4 input AND gate turns its output to 1. Signal goes to reset pin and the counter starts calculating again from 0 to 16, and the same signal also goes to second 4024 ripple counter clock input. This signal comes to clock input every 60 seconds and it works same way than the first ripple counter, but it calculates minutes. Step 3, finalizing. Next, we drill holes for LEDs. My LEDs were 5 mm, so I used a 5 mm drill. LED stays tight in that hole and no glue is needed. I've cut the board so it fits perfectly to the bottom of the box. Step 4, setting the time. I drilled 3 holes to left side of a box for time setting buttons, hours, minutes and seconds. There is also one button on the side which is set button. Step 5, how to read it. Binary clock is easy to read. For example, if you want to set 11 hours 45